Hello students, let's try to understand the mass. Right. This is from the 11th NCERT student science books. Now student, when you talk about the mass, okay, we have learned in the previous chapter that the mass of an object is the measure of its inertia, section 9.3. Okay. Now what we are saying, that is, we have also learned that the greater the mass, okay, we have also learned that no, greater the mass, greater is the inertia. It remains the same whether the object is on the earth, the moon, or even outer space. Thus the mass of an object is constant and does not change from place to place. Okay, that you need to keep in mind, student. That is, mass of object does not change from place to place, right? This is what is the mass. Okay, now student, we are going to understand the meaning of the weight. Okay, so when you talk about the weight, student, then we know that the earth attracts every object with a certain force, and this force depend on the mass m of the object and the acceleration due to the gravity g. Okay, so that is what the weight, if you are talking about, it is the changeable things, student. The weight of an object is the force with which it is attracted towards the earth. Okay, so the weight is the force with which it is attracted towards the earth. That is what is called weight. We know that F is equal to m into a. That is, F is equal to m into g, because acceleration can be changed by the acceleration due to gravity. Now let us try to understand the second one. The force of attraction of the earth, they are saying, the force of attraction of the earth on an object is known as the weight of the object. It is denoted by W, substituting the same in equation 10.14. So W is equal to what is, student? Mg. As the weight of an object is the force with which it is attracted toward the earth, the SI unit of weight is the same as that of the force, that is Newton N. The weight is a force acting vertically downwards. It has both magnitude and direction. So weight is having both magnitude and direction, student. We have learned that the value of g is constant at a given place. Therefore, at a given place, the weight of an object is directly proportional to the mass, say m, of the object. That is what W proportional to m. It is due to this reason that at a given place we can use the weight of an object as a measure of its mass. The mass of an object remains the same everywhere, that is, on the earth and on any planet, whereas its weight depends on its location, because g depends on location. Okay, weight on an object on the moon. What is going to be the weight of object on the moon? We have learned that the weight of object on the earth is the force with which the earth attract, that is what the earth attract the object. In the same way, the weight of the object on the moon is the force with which the moon attract that object. The mass of the moon is less than that of the earth. Due to this, the moon exerts lesser force of attraction on the object. Let the mass of an object be m. Let its weight on the moon be w. Let the mass of the moon be m and its radius be r. By applying the universal law of gravitation, the weight of the object on the moon will be w is equal to g mm into r2m. Let the weight of the same object on the earth be we. The mass of the earth is capital M and the radius is r. Okay, this is mass of the moon, mass of the subject. This is radius of the moon. So now how can you will find? For the moon, here your mass is the no is smaller than here the is smaller, and radius is also smaller. So from the equation we can calculate that is weight on the moon is how much, 2.431 10 power 10, and here is the where is the 1.74 on the earth. Dividing the equation, the moon by it is the 1 by 6 part, student. So weight of object on moon and weight of that is 1 by 6. Weight of the object on moon 1 by 6 into weight on the earth. So this is what the derivation, right, student. So thrust and pressure we will study in the next video, student. Thank you so much.